This is a quick video just trying to get at the idea of collision reaction theory. This is in chapter 12.1 where they go over that concept. So collision reaction theory explains what's happening to the atoms and the molecules and the bonds in the reaction and why some reactions work and some reactions don't. It helps us explain the concept of catalysts and activation energy. So there'll be another video about those things in a little bit. But collision reaction theory requires kinetic molecular theory. And kinetic molecular theory is essentially that if we have a particle, it's going to be moving all the time. If they're solid particles, they're going to be close together and essentially vibrating. If it was liquid particles, they'll be moving freely past each other, but they're very close. So these are two waters. If it's a gas, the particles are far apart and they're moving randomly. That's basically kinetic molecular theory. Molecules are moving. There's different kind of movements depending on the state they're in. And that is related to the intermolecular forces. Collision reaction theory takes it a little bit further. So kinetic molecular theory was mentioned in Chem 20, but collision reaction theory explains what's happening during the reactions. So before we get going, it's helpful to know that if you have a low concentration of gas or of ions in solution compared to high concentration, we're going to get a different amount of collision. And so the collisions are related to that. And that the speed that the particles are moving, or the temperature, is also related to the number of collisions. So a particle that has got a lot of energy is moving with more kinetic energy, moving around very quickly, and you're going to get more collisions with more force. So collision reaction theory is basically if you collide two reactant particles, they may react. But if you don't have a collision, you'll never have a reaction, right? So if there isn't any collision, there isn't any way that they can crash into each other and make a reaction. So for a reaction to occur, reactants must collide. You also need to have enough energy to break the bonds. If you don't break the bonds apart, then you don't have a chance for them to rearrange. And so in order for the bonds to be forming, we need to have them rearrange. And we have to break the bonds, so they require enough energy to break the bonds. So all reactions require both a collision as well as enough energy to break bonds apart. There's more to it than that, though. Just because they collide and just because they've got enough energy doesn't guarantee there's a reaction. You also need to have the correct orientation. So we've got two water molecules. Let's imagine that we need them to collide so that they are going to break the bonds in this way. So if it has a collision and enough energy and the right orientation, then we can break the bonds and make the products. But if they collide the wrong way, then they're not going to actually react because they have to be in the correct orientation. The right sides have to line up for the reaction to occur. The final point in it is that an ineffective collision, so it collides but in the wrong orientation, or it collides without enough energy, has just the particles will rebound off of each other. So the only time that you get an actual reaction occur is when the molecules, which are moving, collide in the right orientation with enough energy to break the bonds. If you don't have that, then we cannot have the reaction occur, and you just get a rebounding of the molecules, which happens most of the time, to be honest. So that's collision reaction theory in a nutshell, and these points are all important. So molecules are moving, they need to collide in the right orientation with enough energy to be able to break the bonds, or they just rebound off each other.